So we have just seen how to have a particular, how to create a particular client using Python. Now we're going to check out how to create a server using Python. All right. Let's say, how do I check for a server using, how do I get a server using Python? Now, what I'm going to do is I'm going to write my Python codes line by line so that, you are able to visualize it very well, how things work in Python. Okay. I'll just come to Python, the Python shell. And at the same time, I'm going to have this terminal also opened up. So both of them are going to be there for me. Okay. Let's say over here, I'm going to create a client, a server socket. How do I create a server socket? First of all, I need to import the socket library, use the socket class in the socket library to create an object called as mysock. Okay, so that's a server sock. Let me call it as, server sock. Okay, now server sock, first of all, whenever you create a server does not connect to the client connects to the server, right? Client needs to connect to the server, but when the client connects to the server should be active on a particular port, right? It should be active on an IP address and on a particular port. So you need to bind the server socket to a particular port. And that is done by using the method server sock dot bind. You are going to use the method called as bind. Bind is again taking a tuple which says what address you want to bind to. Now address is going to be the same Raspberry Pi address, so you can leave it empty. But the port number that you want to bind to is the port number which is, let's say I want to bind it to a particular port number, let's say 1234 or 1235 or whatever. You're creating a new server at a particular port that is 1235. I am binding the server socket to a particular port. Now after binding it to a particular port, I should make this server socket listen. And it will listen at this particular port and the particular IP address. It will listen. Okay. But it should listen for maximum how many clients, or the backlog after which these many clients connect, it should start rejecting. Right? Server sock.listen. Let's say I want to listen to a maximum number of clients. Let me say a maximum number of clients that it should listen is 5. So it is listening. It is waiting for a particular client. So this guy is waiting. Who is waiting? Server socket is waiting. Listening for a particular client. Now a client needs to connect, which means I need to create a client. I can create a client using client.py. I can connect it to this particular socket. But there is a problem. I don't want to do it in that particular fashion. I want to use again netcat. But this time netcat is going to create a client for me. How do I do it? I'm going to say netcat space. I'm going to say netcat, and over here I need to say I want to connect to which particular server. Now server is at which address? 127.0.0.1. Why? Because it is on the same Raspberry Pi. So instead of saying listen, if you say the IP address and if you say the port, it will try to connect as a client, not as a server. Are you able to understand? So you will say 1235. So it will try and connect. Now it has sent a connection request, but this guy, has he accepted? Has he accepted the connection request? No. So he has to accept it by saying server_sock dot accept. He has to use this method called as accept, which will return to him two things: the connection that you have got a request from, along with the address. The connection and the address from which you got a request. Okay. That connection. So if you print the connection, okay, it is nothing but a socket object. Which socket object? Client socket object. And if you say the address, what is the address of the client? The address of the client is same It is 127.0 because it is on the same computer, but it is from a different port number, 52956. That is a port number which the Netcat has created for the client. But the server's port number is what? 1235. Correct? So the address, I've got the connection. All I need to do is, to this particular connection, I can send data. I can say, hi client, okay. So what is the error? It says you require a bytes-like object, not a string. You are sending a what? String. No, I want a bytes inside this. Okay. So if I say, instead of saying hi client, I need to say bytes of hi client. Can you see the hi client came this side? Okay. I can say hi again. It comes hi again, right? Now, what if the client wants to send some data? So before that, I'll just send something more. I'll say hi again from server, but this time I want a, \n. I want a new line to be sent. So I say enter, but now this has come to a new line over here. Can you see a new line? It's now going to print from here. Now, what if I send some data from the client side? I send it to the server. I say, hi server, you've been talking for too long. Talking a while. Okay. Now, this particular data needs to be received by the server, right? The server needs to receive this data. How will you receive it? Con.recv, receive. You should say how many number of bytes should you receive. Okay, you can store it in a variable, let's say data. Enter. And if you want, you can just print the data. What is it? Hi server, you've been talking a while. And because you put an enter, the \n has come here, right? If you send again, hello server, right? Again, I need to say over here, I need to repeat the con.receive 1000, and I need to print the data. It says hello server, right? So this is how this works. Now, if I want to stop the connection with this particular client, I should say con.close. Can you see con.close? And I'm going to stop the server, which is also going to be server sock.close. So you're closing the connection and you're closing the server, right? Oh, sorry. server underscore sock is, sorry. So you're closing the server sock and the client socket. So this is about how to use the socket, how to program the socket using the socket library. Hope you have understood this. Now we are going to go to an application using this, that is controlling an LED over the network by sending on and off. We're going to do that. All right.